So, good day students, and welcome to the second lesson in the course concerning biomass for energy. As you remember from the course introductory, is biofuel not necessarily the same as biomass. Today, though, it's very common to use the word biofuel only for liquid fuels aimed for cars. And this is a restriction that does not comply with the internationally accepted standard EN 14588. So in this introductory presentation we will have a look at what constitutes a fuel, and then we will discuss some general aspects of importance when it comes to biofuel. The first lesson was spent on explaining the fundamental properties of biomass. As you will remember, were the properties of the cell fundamental. Among these are the physical structure of the cell, like is there a cell wall or only a cell membrane. The chemical contents of the cell were also important, like is it a sugar-rich cell from fruit biomass or a keratin-rich cell from a hair. The water content of the material, like is it a sludge with 95% water, or is it a piece of air-dried wood? These will all be factors that makes the biomass exhibit a wide variety of properties, together with other factors, of course. But to finally be useful in the energy system, we have to guarantee that the biomass becomes a combustible substance. Following standard terminology, is a biofuel a combustible substance that has been produced from biomass. There is a side condition, namely that the biomass must not be contaminated. We will come back to the word combustible. Another definition of a fuel that is sometimes used is that a fuel is a tradable energy carrier, a commercial energy carrier. So, let us say that a biofuel is a tradable substance that contains chemically bound energy that can be released through combustion. And let's now have a brief look at some different assortments. Let's start with societal waste, municipal solid waste, or MSW. An old newspaper is certainly waste, but it can be recycled and used for a new newspaper, and then it is a material resource. Or it can be burnt to help boil an egg or to raise steam in a power station, and then it is a fuel. This holds true for quite a lot of waste fractions. Of course, many waste fractions are not biomass at all, like plastics made from fossil oil, but many are. Some of the biomass waste can be combusted as it is, like a broken wooden cutting board, so that is a fuel. If it is not contaminated, it is a biofuel. Some of the biomass waste cannot be combusted as it is, like the feces you flush down the toilet, but it can be digested, and the methane produced is a biofuel. You will notice that the Busy Plan handbook chapters I mention in this slide are concerned with putrescible biomass and other biomass. The reason for that is that when it comes to woody biomass and many of the herbaceous biomasses, do people already from the beginning understand that the solid material itself is a fuel? So the conversion from biomass to biofuel can be very simple. Drying a piece of soaking wet wood will convert it to a biofuel. Actually, drying most any wet biomass, animal dung, fish rinsings, apples or whatever, ultimately makes the biomass combustible, and then it is a fuel. Dried dung is one of the most ancient fuels used by mankind. As an oddity, dried fish rinsings were used as a complementary fuel in glass melting furnaces in the Middle East already in the 1300s. So, drying is actually one of the most important conversion processes. Conversion processes can be classified in many different ways, and there is no generally accepted standard for this. Here I will just mention a few different things that may serve as a help when thinking about this. And the first one I want to mention is drying. Drying does not change the chemical composition of the combustible material, and it does not change the physical properties of the combustible material. Remember that the part of the material that is combustible is only the dry substance, and that does not change just because you take away the water. A second way may be to first dry the material, unless it is already dry, and then to make it more compact, like making wood pellets. In this case is the density changed. The heating value is not changed, but the energy density is. We will come back to that. You can also grind the material to produce a fine powder. Such fuels can be used in pulverized fuel burners. A third possibility is to alter the chemical composition of the combustible material, but maintain its physical state. One example of this is the low-temperature pyrolysis process known as torrefaction. Doing that may change the heating value of the material, and it may also add other positive effects. Torrefied wood pellets are less sensitive to moisture and to water than non-torrefied pellets. The energy demand for grinding is also lower. Another way is, for example, esterification or hydrogenation, like the production of HVO for a diesel substitute in car engines, or the production of rape methyl ether, again for car engines. In these cases, you start with an organic liquid oil made up from a mixture of natural ingredients, and your final product is still a liquid, but with a well-defined chemical structure. Another example is the use of sugar-rich fruit sludge to produce ethanol by fermentation. You may also alter the chemical composition and the physical state by aid of biochemical processes. Anaerobic digestion of sewage sludge or animal dung to produce biomethane is maybe the most well-known example. Or you can use thermochemical processes like liquefaction or gasification to alter the chemical composition and the physical state of the combustible substance. A very common misconception is that processes like gasification or pyrolysis or other conversion processes are ways to use the energy, but they are not. It is just the other way around. What you want to do in all these processes is to preserve as much of the energy as possible from the raw material and keep it in the product. So what we will do in this lesson is to have a brief look at a number of conversion processes. There will be no details, and that is because there is ongoing research and development in this area, and what I want to present in this lesson is a material that will stay up to date for a long time. So I only want to give you such basics that will stay true for a long time. In case you want to find the current state of the art, you will have to search for that by yourself.